Welcome to Algebra Prep Academy. The lesson for today is solving systems by graphing method.
In order to find the answer to a systems of equations by graphing, we must plot the two lines and see where they intersect. The answer is the intersection point as a coordinate point, x, y. In this example, we will be graphing y is equal to x minus 6 and y is equal to negative 2x plus 6. We will be graphing y is equal to x minus 6 first with the y-intercept at negative 6. We use the concept of rise over run to find its slope of positive 1. So we'll go up 1 and to the right 1, up 1 and to the right 1. Similarly, for negative 2x plus 6, we start at positive 6 and go down negative 2 and to the right 1 using rise over run. The point of intersection is at 4, negative 2, where x is equal to 4 and y is equal to negative 2, and that is the answer to this systems of equations. In order to check if our solutions are correct for the first problem, we must plug our solution back into each of the equations and make sure that they equal each other. This means that for this set of equations, we must plug in x is equal to 4 and y is equal to negative 2 to both of the equations. The first equation will end out to be negative 2 is equal to 4 minus 6, which is negative 2 is equal to negative 2, showing that the solution is correct for the first equation. We then do the same thing for the second equation by plugging in negative 2 is equal to negative 2 times 4, all plus 6, which is equal to negative 2 is equal to negative 8 plus 6, which is equal to negative 2 is equal to negative 2. In this next example, we will be graphing y is equal to negative 3x plus 2 and y is equal to 2x minus 3. We'll be starting at positive 2 and going down 3 and to the right 1 because slope is rise over run. In this next equation, we will be starting at negative 3 and going up 2 and to the right 1 because of rise over run, where the rise is 2 and the run is 1. Their point of intersection is 1, negative 1, where x is equal to positive 1 and y is equal to negative 1. We will now be checking to see if the solution that we found in the graph of our example matches. In order to do this, we will be plugging in the answer to both of the equations. So in this particular problem, we will be plugging in x is equal to 1 and y is equal to negative 1 to each equation and seeing if the solution works out. This means that for the first equation, plugging in the answers will work the equation out to be negative 1 is equal to negative 3 times 1 all plus 2, which is equal to negative 1 is equal to negative 3 plus 2, so negative 1 is equal to negative 1. In the same way, we will do the same thing to the second equation, which will be negative 1 is equal to 2 times 1 minus 3, which in the end works out to be negative 1 is equal to negative 1 as well. In this example, we will be graphing y is equal to 2/3 x minus 2 and y is equal to negative x plus 3. For the first equation, we start at negative 2 and go up 2 and to the right 3 using the concept of rise over run, because the slope is 2 over 3. Then, we form a line by connecting the points. We use the same concept for the second equation by starting at positive 3, which is the y-intercept, and going down 1 and to the right 1 because the slope is negative 1, which is negative 1 over 1. Their point of intersection is at 3, 0, where x is positive 3 and y is 0. We will now check to see if the answers that we found in this example were correct. We will do so by plugging in the answers back into the equations and seeing if the equations work out. In this case, that means that we will plug in x is equal to 3 and y is equal to 0 into each equation. For the first equation, y is equal to 2/3 x minus 2, this works out to be 0 is equal to 2/3 times 3 minus 2, which is equal to 0 is equal to 2 minus 2. So 0 is equal to 0, and therefore the solution is correct for this equation. Now we will do the same for the other equation, which works out to be 0 is equal to negative 3 plus 3, which is 0.
Thank you for watching. Like and subscribe for more videos like this.